Question 20. A nucleus of nitrogen-13 consists of 7 protons and 6 neutrons. This unstable nucleus undergoes beta plus decay, ignoring any emitted leptons. What is the total number of up quarks present in the nucleus immediately after the decay? This problem tests our understanding of nuclear decay, specifically beta plus decay, and how it affects the number of up quarks in the nucleus. Let's begin by recalling what we already know. We know that beta plus decay converts a proton into a neutron, emitting a positron and neutrino. We know that protons are made up of 2 up quarks and 1 down quark, and neutrons are made up of 1 up quark and 2 down quarks. We also know that the total number of up quarks in a nucleus is the sum of up quarks in all protons and neutrons. Finally, during beta plus decay, an up quark in a proton changes into a down quark. Now, let's think through the solution step by step. We begin with 7 protons and 6 neutrons in the nitrogen-13 nucleus. To count the total number of up quarks in this nucleus, we first consider the contribution from the protons. Each proton contains 2 up quarks, so the number of up quarks from the 7 protons is 7 times 2, which gives us 14 up quarks. Next, we consider the neutrons. Each neutron contains 1 up quark, so the number of up quarks from the 6 neutrons is 6 times 1, which gives us 6 up quarks. Thus, the total number of up quarks in the initial nucleus is 14 from protons plus 6 from neutrons equals 20 up quarks. Now, let's focus on the beta plus decay. During beta plus decay, a proton converts into a neutron, and in the process, 1 up quark in the proton changes into a down quark. As a result, we lose 1 up quark because the proton has converted into a neutron. After the decay, the new nucleus contains 6 protons and 7 neutrons. The number of up quarks from the remaining 6 protons is 6 times 2, which gives us 12 up quarks. The number of up quarks from the 7 neutrons is 7 times 1, which gives us 7 up quarks. So the total number of up quarks after the decay is 12 from protons plus 7 from neutrons equals 19 up quarks. This is our final answer. What did we do? We wanted the total number of up quarks in the nucleus after beta plus decay. We began by counting the up quarks in the initial nucleus, which had 7 protons and 6 neutrons. We then accounted for the conversion of 1 proton into a neutron, which reduced the total number of up quarks by 1. Finally, we recalculated the total number of up quarks in the new nucleus, which consisted of 6 protons and 7 neutrons. Now let's address some potential misconceptions that could arise in solving this problem. Some students may forget to include the up quarks from neutrons when counting the total. They might focus only on the protons, which could lead to an incorrect answer. To avoid this, make sure to count the up quarks from both protons and neutrons. Another common mistake is forgetting to adjust the number of up quarks when a proton undergoes beta plus decay. Since a proton converts into a neutron, 1 up quark changes into a down quark. If this step is overlooked, students might end up with 1 extra up quark in their final count. Remember, always reduce the number of up quarks by 1 when accounting for the proton to neutron conversion in beta plus decay. Here's the summary of the essential ideas. Protons have 2 up quarks and 1 down quark each, while neutrons have 1 up quark and 2 down quarks each. Also, in a beta plus decay, a proton converts into a neutron, so 1 up quark changes into a down quark. Hence, the total number of up quarks in a nucleus is the sum of twice the number of protons and the number of neutrons. Here is our final question for this paper. How did you do on this one? And hope there was lots to learn and also reinforce understanding. Definitely engage with more of our materials and have fun learning.